Hello guys, good evening everyone. Welcome to Pantech Solutions and I warmly welcome you for the series Raspberry Pi Masterclass Day 3. So in this session we are going to see embedded system as with digital IO. So here digital IO in the sense we already know about in the embedded system basic there is an analog as well as a digital. So on that, so first of all we are going to see a digital IO how to use a digital pin interface with our Raspberry Pi. Okay. So these are the concept which we are going to see in this session. I hope you all ready. So if you are ready, please put I am ready in your live chat. Okay. So we'll go for the session. So before going on to the session, same as there is an announcement. So attendance link will be available around 6:30 p.m. So once the session is completed, start filling up the attendance form. Until then, don't rush up for the attendance form. So once we just session is completed, then you can fill up the attendance form because attendance form will be available still now after 12 hours even. Okay. So we'll move on to the session. Okay, so in this so first of all we are getting response from Aniket Satpal and Mohammed Muruddin is asking for attendance. Nikhil, so a lot of people are telling like I'm ready. It's really great. Thank you for your kind response. So we'll move on. So table of content. So first of all, in this session, first of all, we are going to see about embedded system overview, and I'm going to give you some kind of methodology to analyzing sensor modes. Like a lot of people may like confused about sir, I just worked on PIR sensor. I haven't seen IR sensor. I don't know how to work on IR sensor, and I don't know how to program for IR sensor. But I just programmed for PIR sensor. Actually, it is not like that. So we need to learn about like basic methodology, how to start working with sensor and how to identify the sensor modes. Those things I'm going to give you a little bit tips. And digital IO, so we are going to use digital input and then digital output interface with the Raspberry Pi. From here we are going to handle the 40 GPIO pins of the Raspberry Pi. And finally, of course, we are going to have a discussion and science discussion and a Q&A. Of course, as a lot of people, a lot of participants have requested to put tech news, continue the tech news, because for past two sessions we have continued tech news for each and every day. So as the request is accepted, so I'm just going to provide tech news of each and every day. Okay, so I hope you like it. If you like it, please put I like it in your live chat. Okay, so we'll move on. So prerequest, so from this, apart from the basic hardware which we required, other than that, here we are going to use a LED with 330 ohm resistor and switch our IR sensor. Okay, so here first of all, before going on here, the first of all we need to discuss about the basic embedded system, right? So just don't just forget about these diagrams. Okay, so first of all, see about embedded system. Okay, so embedded system is kind of like combining the hardware and then software to deploy or to make it for certain application. Okay, application may be anything. So let us take about like your ATM machine. Okay, so there is a hardware, right? So hardware in the sense we have our own machines and buttons and every lot of other interfaces there, buttons or touch screen, lot of etc. Other than that, it also requires one software to make it to be booted to display it in a window. Okay, so that is combination of hardware and then software to make it as which is specifically made for a certain application. Okay, so that is embedded system. So on that embedded system, first of all, a lot of people may have a confusion like how to identify the sensor, because I have seen this sensor module. This is a PIR sensor, infrared sensor, but I haven't worked in PIR sensor. I don't know about it because so let us take assumption like if you are very new to electronics, I'm going to give this module to you. Okay, so this is the IR sensor, so I'm going to give this module to you. So what you'll say, I don't know what is this, I don't know how to program, right? That's the first sentence we used to have, right? But other than that, there is a methodology to have a to finding out what is kind of module is, either that is either that is kind of digital or either it is analog. So before that, we need to identify only its name and its function. Okay, so I'm going to give this module and I'm going to tell you this is IR sensor. Okay, so I'm sorry. Okay, so this is the IR sensor, and this IR sensor can be functioned like whenever you are crossing this hand, so it will give you some response. Okay, so like whenever I'm going to strike this my hand like this, so it will give some response. So for each and every time I'm going to cross this hand with this sensor, it's going to give some different response. Okay, but Still now we don't know what kind of sensor is, either it is a analog type or digital type. Okay, so while talking about the analog and the digital, so analog is in the sense it is having a variation like sinusoidal. Let us take a sinusoidal. So it is like variation of positive and negative, positive negative. So that is normal basic analog. But other than that, if you are discussing about digital, so digital is nothing but a line, like not a line, like 0 or 1. Okay, 0 means 0 or 1, or 0 to 5 volt, or 0 to 3.3, 0.2 some volt. Okay, that is a kind of digital. Like digital signal, the best example is the square pulse. Okay, that is 0 1. There is no intermediate value, either 0 or 1, or in the sense 1 or 3.3 volt or anything, but that value going to be either 1 or 0. Okay, so that's the main thing. But while talking about the analog, so it is having a linear variation. So the best example, you just look over the switch box, the switch board, the junction box which is nearby you. Okay, just to see the junction box. So it contains the switch, right? So switch is in this nothing but, so if you're going to do one thing, either it is on or else it will be off. Okay, so that is the one thing. But if you see the potentiometer which is used to adjust the speed of the fan, okay, what you'll do? So you will just turn out that trim pot or that potentiometer from 0 to 1 level. Okay, on the 0 level fan won't rotate, like for fan will be in the stop position, and whenever you are increasing the speed of, or whenever you are adjusting that potentiometer from one position to another position, then you can able to change, or then you can able to see the linear increase of speed in that fan, right? So this is the best example of analog. Okay, so was one value to another value. Okay, so like linear increase, like 0 1 2 3 4, like up to like some of the values. So that kind of variation is known as a kind of analog. The digital is main thing is either 0 or either 1. Okay, that is the best example of analog than digital. So first of all we need to identify we don't know, right? So because if you are seeing this module, so now you know the name and then purpose of this module, but still now you don't know about either it is analog or either it is a digital. But here they have just presented as out. Okay, out means data. Okay, so here still now we don't know what type of response is, either it is analog or either it is a digital. And another main thing you just want to remember is whatever the sensor module or whatever may be, okay, it is going to return you nothing but a voltage. Okay, please remember this concept, guys. Don't forget about like this sensor will give voltage, this sensor will give some of the value. Not like that. Each and every sensor module, it is nothing but it going to give only the voltage. Okay, from the voltage values variation we can able to identify, or we can able to segregate that is an analog type of sensor, or that is a digital type of sensor. Okay, so here we have this IR sensor module. Okay, so this is IR sensor module. Okay, so here it contains 3 pins, that is VCC, ground, and then data. Okay, so here it is. So what we are going to do for simulation, so because we need a multimeter and a voltage supply for those things, so I'm going to introduce to another like simulator for Arduino participants. I think you already know. So that is Tinkercad. We just type in Google Chrome, that is Tinkercad. It is not for Raspberry Pi. It is only for Arduino. But other than that basic circuit, you can do the simulation in here. Okay, you just note it down. I hope you all have your notes and then paper, right? If yes, please put I'm in yes in your live chat. Okay, so here we have the Tinkercad. I just already created an account. On after create an account in Tinkercad, so here there is option called 3D designs, circuits, code blocks, and lessons. So please click circuits here. Okay, so after clicking a circuit, so there is actually I have already created this. Okay, you can drag and drop you can drag and drop like a voltmeter, the power supply, and those things. Okay, so yeah, now here what we are going, yeah, a lot of people are telling yes, it's really great that you have the notes with you. Really great habit. Okay, so please follow it. So this is the Tinkercad used for basic simulation. So here what I am going to do is I am going to do little bit of simulation to identify what kind of module or what kind of sensor it's going to be. Okay, so for example here we are going to take 2 modules. One is PIR sensor. Okay, another one is trim pot, that is potentiometer. Okay, so you just here there is option called search box. So here in search box you can search like a multimeter. Okay, so multimeter is here, you just drag and drop. Okay, so and then power supply. Okay, so you just type power supply. Okay, so here there is a power supply, you just drag and drop. Okay, and then like potentiometer, and everything is available in the search box itself. Okay, you just do the drag and drop. I just already connected it. Okay, so first of all we'll see the example for potentiometer, the knob which you have used in your fan adjustment, like speed adjustment. Okay, so for those things. Okay, so first of all, this is the circuit, but here what we did, here in this trim port there is a three port, three terminal. Okay, so one is positive and another one is negative and another one is data. Okay, so on this three parts, so first of all what we are going to do, we are going to take is for power supplies, because trim port, of course, whatever will be the module or the sensor, definitely we need power supply, right? So for that I'm going to use the simulation based power supply. From that power supply, one end is connected to VCC and another one is connected to the ground, as same as like the ground is also connected with multimeter, and the multimeter's positive end is connected to the potentiometer. Okay, so now let us do simulation. So here there is a simulation, you just click start simulation. So first of all, you initialize. So now you are seeing the voltage, that is 5 volt. We just passed 5 volt, and here in the multimeter you are seeing 0.00 volt. Okay, so now you can able to increase like this. Okay, now I think you can able to got this. So here I'm just adjusting the trim pot. So instead of doing it in a real time, here we are just doing a simulation. Okay, so here I'm just going to adjust this knob by clicking and dragging. Okay, so I'm adjusting from 0 volt, 0 to or 1 position to another position. Now you can able to see the like linear variation in the voltage. Like it start from 0.00 volt and then like 300 millivolt, 1.2 volt or 2 volt, 3 volt, and then 4 volt and then 5 volt. Okay, so this is the best example for analog. Okay, so I hope you understand this. So this is the best example. So whatever will be the module, so definitely going to have a 3 pins. One is VCC and another one is ground and another going to be data. On the data pin, you just place the positive end of your multimeter and place the negative end to the ground pin of the module. Okay, do it in a real time. So whenever you are seeing a new module or sensor. Okay, so this is the best example for analog. So let us see about digital sensor. So here we are using a PIR. So first one is going to be a VCC. So VCC is given to okay, this is data actually. First one is data and second one is VCC and third pin is ground. Okay, two pin is connected to the power supply and another pin is given to the data. So my wire is given and just dragged into as like data pin, as like a potentiometer. Okay, so and after doing it, what we are going to do is we are going to start the simulation. So let us check the PIR sensor. Okay, so this is the checking of PIR sensor. Okay, so this is the PIR range where you are getting exactly like around 4.9 volt directly. That is linear variation in the voltage. Okay, if it is in range, it is giving 4.98 volt. If it is not detected, it's going to give 0 volt. If there is no linear change between 0 to 5 volt, like 0 volt, 1 volt, 2 volt, 3 volt, not like that. It is directly giving either 4.98 or 0. Okay, so this kind of sudden change of variation, that kind of process is known as actually it is a digital type of sensor. Okay, so I hope you got this. So if you got this, please put I got this in your live chat. Okay, so this is like whatever the new module which is hold by you. Okay, you just check by using this kind of methodology. Take your multimeter and give the power supply to the module. The power supply can be like a basic 5 volt and then ground, and take the another that positive end of the multimeter and give it to the data pin and check or observe the output voltage there. So from that you can able to identify that either that is an analog or either that is a digital. Okay, so that's up to here. Okay, so it's up to like a basic identification of analog or digital. So here we are seeing a pinout of Raspberry Pi. So in this Raspberry Pi pinout, so first of all I already told you, so for Raspberry Pi, in each and every pin is representing a two pin names. So one pin name is board pin name and another pin name is BZM pin name. Okay, so here this pin, no, so pin 01, 03, 05, 07, 09, 011, 13, pin. So these pin names like 01 and 02, 03, 04, 05, 06. So likewise, there are these kind of order 0, 1, 2, 3, 4, 5, 6. So this pin name is known as board pins. Okay. Other than that, there is also another pin name like GPIO 2, GPIO 3, GPIO 4, GPIO 17, GPIO 27. So these pin names are known as BZM pin names. Okay. So we are going to use this BZM pin names. Okay. So always so whatever, so for example, if I'm going to tell you like connect the IR sensor in the pin number 12 means, so don't connect it in here, so we just connect it in this one GPIO 12, not only 12, you need to connect the sensor to the GPIO 12. Okay, so that's up to here. So I hope you got this. We got a lot of I got it response. It's really great. So thank you so much for your response. So this is the circuit diagram. Okay, so we are going to give the circuit diagram for basic digital IO. Okay, so we are going to start with the digital IO. So here you are seeing the digital output LED. So LED connection in the sense Raspberry Pi with LED with 330 ohm or 220 ohm resistor. So I hope you all know the purpose of using resistor. So here what is the purpose is like to block or to like restrict some of the flow of current. Okay, so like that is used for protection for LED. Otherwise, if you are giving direct 9 volt or something like that, definitely you will see like bursting, or you can able to sense lot of smell in there. Okay, burst smell. Okay, so that to restrict the flow of current to the certain component, we are using a resistor. Okay, so here there is a connection. So LEDs. So in this hardware you can able to see the connection. So first of all, here we have Raspberry Pi. So always please place the Raspberry Pi that USB port is facing towards you, so that you can able to see that like the pin number identification will be very easy for you. Okay, so and then here we have LED. Okay, so on that LED, so first of all you need to identify which one is anode and which one is cathode. Okay, like positive and negative. So of course we need to identify it, right? So the best like the best way is to identify cathode and then anode is, so if you are going to if you just see this LED properly by in close in contact means, so there will be one cut which is present inside that LED. Okay, that cut resembles that is an anode, and without cut which will be straight, so that going to be cathode. Okay, so another way to identify the LEDs anode and then cathode is long wire. Actually, whenever you are seeing a new LED, so one wire going to be very long and there is only a short wire also there. So long wire represent anode and short wire represent the cathode. Okay, so that's up to here. So what we are going to do, we are going to give the connection here. So first of all, let us connect here. So I'm just going to connect it with the breadboard, and I'm going to take the another resistor and I'm going to give it in the positive side. Okay, so resistor is also connected. Okay, so and then let us take two jumpers. Okay, like female to male jumper. Okay, when there is like a tip in there, so that is male, and without tip that is a female. Okay, so male to female jumpers here. So I'm going to take and I'm going to give it in the one end of the resistor and another end to the LED second. Okay, so that's it. I've given the connection. So now we need to connect the ground. So you just see the pin diagram. On this pin diagram, you are able to see the ground pin. So actually one from the right side. So from the right side that is 5 volt, 5 volt and then ground. So that is the third pin. It is going to be ground. Okay. So third pin I'm going to give it to the ground. Okay. So black wire is connected now. So that is like ground connection is given. Okay. So ground connection is given, and then what we need to do, we are going to connect the second pin. Okay. Next that is the data pin. So here the data pin, to connect this data pin, we need to connect it in any GPIO pins of Raspberry Pi. So here let us use this second pin. Okay, that is GPIO 02, not this two guys, because here this two represent 5 volt, but we are going to use the BZM pin names. So that's why GPIO 2 resembles that. That is this on the left side, that is the second pin. Okay, so that is the data pin. I'm going to connect. Actually turned on. Okay, so no problem. So we just connected an LED. It's already glowing because it may be like data pins is already in on state before. Don't worry. Okay, we just connected. Okay, that's it. LED is given, the LED connection is given. I'm just expanding the hardware screen. So here LEDs one end is connected to the resistor. So here the resistor value is 330 ohm. Okay, it's 330 ohm resistor, and one end of the resistor is connected to the LED is positive end, and another LED of another point of resistor is connected to the data pin, and another point of the LED is connected to the ground pin. Okay, so I hope you got this. So it's very simple circuit. Okay, so that's up to here. So what we are going to do, we are going to work on the program. So I hope you all remember the yesterday session, like how we have done like a headless startup, and how we have opened our Raspberry Pi and we have installed IDLE too, right? So I hope you remember. So if you remember, please put I remember in your live chat. Okay, so let us open Raspberry Pi window. Here there is Raspberry Pi window. So just already yesterday itself we have explored some of the menus, like this is the browser and this is the file manager and this is the terminal, and on the right side we have Bluetooth and then Wi-Fi and then sound. Okay, so first of all we're going to open a file manager. Okay, so whenever you want to create a folder, you just right click and create a new folder. Okay, but if you want to create a Python file, you just right click and click new file. Okay, on that new file you just want to name like LED. Okay, so LED or test. Okay, you just want to name it with its text extension. So what is the Python file's extension? So you just, that is a .py. Okay, so test.py, and then click OK. So then you will get the test.py. Okay, the test.py file will be there in the home py area. Okay, so that's the main thing. If you want to create a folder, right click and click new folder, and if you want to create a new file, right click and click a new file and type its name and then with its extension. Okay, so here we are going to use a Python programming for programming this Raspberry Pi and all. So we are going to use this .py extension. Okay, so test2.py. So I've already created the code. So that is a masterclass day 3. So digital output. Okay, so this is the Python file. So on the yesterday session itself, we have already installed a Python IDE, right? So I'm once again tell you like how to install Python IDE, because whenever you are freshly installing like Raspberry Pi OS, so it don't have IDE. So what we need to do is just open this terminal that is black color, which is present here, and you just type sudo sudo space apt hyphen get space install IDLE3. Okay, you just take a snap, guys. I hope it is smart work. Take a snap. Okay, you just and then press enter. And the main thing, your network should be connected with the internet. Okay, so that's it. Sudo apt get install IDLE3. Okay, so with the help of that, you can able to see the IDLE in this programming section. Okay, here there is Python 3 IDLE. Okay, so and whenever you are trying to program in the Raspberry Pi, better to go for like IDLE, because it is like very easy other than Thani. For personally, I'll suggest you that you to use IDLE. So we are going to make it to be like a default to run on Python 3 IDLE. So what I'm going to do is just right click the file name, that is Python file name, and go for the properties, and in the open with option you just chose Python 3 IDLE. Okay, so I hope you got this. So we chose Python 3 IDLE and click OK. Okay, after click OK, so it will defaultly it will open with IDLE. Okay, so this we got, this is IDLE. Okay, so that's up to here. So we'll start from the basic programming. So first of all, I would like to introduce about the Python IDLE. So first go for the programming and open Python 3 IDLE. Okay, so this is going to be the shell. So shell is nothing but the output window. Okay, where you can able to see your outputs. Like if you are printing like a plus b is equal to c means, so if you put c, print of c means, so the value will be printed on this area. This is known as Python shell. Okay, so here there is a menus called file, edit, shell and everything. So main thing you want to remember the file. Of course, in the file whatever will be the, it will have the save as option, print, and then exit and then open and the new file. So those things will be there. And edit, of course, like copy paste and then find, replace, those things. And the main thing you want to remember, that is like debug and then option and then window. So those things. So shell here we won't do lot much. Okay, so whenever you want to create a file from the IDE itself, you can go for the option called file. Okay, so file and then new file. Okay, so this will be like untitled window. So this is the Python file where you can write the code. Okay, so writing the code in the sense, so I hope you all know the like basic C programming, right? So same as like here, but little bit syntax will be different here. But when compared to other programming, so it will be very like user language. For example, in the if loop. So for example, in the C language, what you will do, like if you want to check multiple condition, you will put that ampersand symbol double times, right? So if A is equal to B, sorry, if A greater than B as well as A not equal to B means, so that kind of condition you will put ampersand on between, right? But here you can able to put and or not. So like directly you can represent a logical operation. So like for example, if you want to put like if you want to multiply like addition or subtraction, you can directly like you can do that like this. Okay, so like A is equal to 5, B is equal to 5, and then C is equal to A plus B, and then print of C. Okay, simple. Okay, just to save it. So while saving, you just want to name it. Okay, so PyTest 3. So this is extension which is already present, that is py. Okay, just that's it. Okay, and in this window, so there is a run option. Okay, so run and then run module. Okay, so 12. Okay, so it is very simple to use this Python programming. So it contains the shell going to display the output, or else this is the editor window where you can able to write multiple number of codes. So there is another option like here you can able to write the code, but it is line by line execution. A is equal to 5, B is equal to 7, and C is equal to A plus B, print of. Okay, so it is another way to write the shell. Like if you want to test only one syntax means you can test with the help of the shell itself, or else if your code lies like more number of lines, you can write it in the editor. Okay, so this is up to now like very basic thing. Okay, so I hope you got this. If you got this, please put I got this in your live chat so that we can proceed further. Okay, so that's up to here. So and then basic looping conditions in the sense like so for looping and each and every program, because we are not going to learn Python programming first and then embedded system and then Raspberry Pi. We are going to learn Python programming with this Raspberry Pi knowledge parallelly, so that we'll get an idea like whatever the project. So for example, if your project requires the if loop, so we'll learn that syntax to use that if loop as well as the program or the project. Okay, then you will get an idea like then you will have that practical knowledge or application based learning. So that is a better way, that is like Pantech's idea. Okay, so I hope you like that. Okay, so what we are going to do, we just did like print C. Okay, so this is the code. So same as like for if loop and those things we'll see on the upcoming sessions. So I hope you got this. Okay, so this is basic like addition and then subtraction as those things. Okay, so let us introduce about furthermore syntax. Okay, thank you guys. A lot of people are telling I got this. Really great. So first of all, I would like to introduce about libraries, because whenever you are using this Raspberry Pi kind of thing, it is nothing but a library. So like you can use a libraries. So as like Arduino, I hope a lot of you participants have attended Arduino class also. So I think they may know about the libraries because we have handled a lot of libraries there. Same as like here also we are going to use some of the libraries. So on the first library which we are going to discuss, that is RPA.GPIO. This is nothing but a wiring pipe. I hope you all in my sync, guys. I'm not putting this in each and every detail in presentation. Please attend, have your attention on complete session. Have your user notes, okay, especially. Okay, so here import RPA.GPIO as GPIO. This is nothing but the library which is required or which will be helpful to access the GPIO pins of the Raspberry Pi, because we are using Python programming, right? Python programming can't able to understand how the Raspberry Pi is there, how the Raspberry Pi help, that the pin diagram, the pin configuration, what is mean by 12. So if you say Python like A is equal to 12 means, it will take that as an integer number. It don't know about like that is a pin name, so that it don't know. So for that we need a certain library which going to handle the GPIO pins of the Raspberry Pi from the Python programming. Okay, so that's up to here. The first of all, import rpa.gpio as GPIO. So here what it means, so this is the library which is required for accessing the GPIO pins of the Raspberry Pi. So okay, so I hope you got this. So give me a minute, I'll try to increase the font size. So 16, so we'll apply the font. Okay, so digital output .py. Okay, so here we have this we just increase the font size. Okay, so that's up to here. So import RPA.GPIO or GPIO. So here this is nothing but the library which is used for the basic wiring file library. And what is that? The second option, that is import time. Okay, so here time is nothing but delay. Okay, you can talk it as a delay now, but because the time library is useful for taking the current time also, but also it will be used for taking like kind of like current time, or taking a delay, like initializing the delay. For example, if you want to blink an LED, like on for 1 second and off for 1 second, so on that time definitely we need the time that we need to specify, that is a 1 second, right? So we need to specify that is a 1 second or 2 second or 3 seconds. So like that we need to specify the time, right? So whenever your code requires the time kind of operation, you need the library. That kind of library can be imported with the help of the keyword called import. So I hope I'm going to type one line. So I hope you remember that line, right? So let us see this. I think a lot of people may know about this. So what is that? This is standard input and an output, right? So we used to import in that C programming. So what are the programming? So if we know the programming or not, so definitely we'll write the two line. One is studio.h and another one is codion.h, right? So that's up to here. So this is on the C language, C programming, which you used to have. But in the Python programming, if you want to import a library, you can simply use the syntax called import. Okay, so import and then rpa.gpio as GPIO. So here you may ask, so why you are using import rpa.gpio will import the library, but why you are using as GPIO? So as is nothing but, instead of calling the complete name like rpa.gpio again and again, instead of that I can call simply as GPIO. So in a single word, either you can put a also, like instead of using that word called rpi.gpio, I can use the word called a. Okay, so that's the purpose of using that as after the library. Okay, so here and main thing guys, so whenever you are trying to import the library, don't forget to put RP is capital and I is small, that is uppercase, RP is uppercase, and then I is lowercase, and dot GPIO is going to be uppercase. Okay, this is your wish, you can change whatever you want. Okay, but this name it should be like mandatory to represent in a proper manner. Okay, so that's up to here. So rpa.gpio as GPIO, and import time. So time is used for like taking a time delay. Okay, so and after that what we are going to do, we need to initialize the pin names. Okay, so pin names in the sense we need to initialize what kind of pinners we are going to use. Okay, so on that first of all we'll introduce the another pin mode. Okay, so here we need to specify what kind of pin mode we are going to use. Okay, pin mode in the sense what it means, like we have already discussed about the pin names of Raspberry Pi, right? So one there is the pin name can be represented as a board pins, or it can be represented as GPIO pins or BZM pins, right? So the presentation which we have seen. Okay, so see here, so GPIO in the sense, so if I'm going to represent BZM pin names, I need to specify like rpa.gpio.bzm. Okay, BZM means we need to specify, or we need to select what kind of mode which we are going to use it for choosing the pin names. So here we are going to use the BZM pin modes. Okay, so it can be done with the help of the syntax called GPIO. So the GPIO means the name which we have took from here, GPIO.set mode. Okay, so we are going to set the mode of the pin name which we are going to use. So we are going to use GPIO.bzm. Okay, so GPIO.bzm, and after choosing the GPIO.bzm, so we need to choose like we are going to specify the pin names, or the LED or the connection or the pin which we are going to use. So those things we are going to specify it here. Okay, so on that first of all I'm just going to specify one name, that is LED. You can take LED pin, so that is user defined variable. You can name it anything like what you like. Okay, LED pin is equal to 2. So here 2, what it means 2. So here what the 2 means, so I'm just showing the pin diagram. So here 2 is not representing the board pins because I have configured that into a BZM pins. So it's going to look for the GPIO 02. Okay, so that is, since it is a BCM, you just want to look for the numbers which contain GPIO, that word. Okay, you just see that. Okay, GPIO 02. Okay, so that LED pin is equal to 2 means GPIO 02. And here, and after choosing each and every pin, we need to specify what kind of modus, like what kind of type of pin is. For example, now you are using a LED, right? So LED means either it is an output device or input device. Ping your answers in the comment box or live chat below. Okay, so the question is LED or motor. So either it is an output or input device. So output means I'm going to give the something, I'm going to give something, it's going to display something. Okay, I'm going to give some input. Based on the input, it's going to respond or it's going to react. That kind of device are known as output. While talking about the input, the sensor going to do something. We are going to read something from the sensor, like electrically or electronically. We are going to read from the sensor. Okay, so that are known as input. Okay, so we are getting the response from Aniket Satpal, Surya, and then Kiran. So it's really great. That's the output device because based on our input, it's going to react. So reaction in the sense, if it is taking LED, if I'm going to give the input supply, so it's going to glow. If I'm taking a motor, if I'm going to give the supply, it's going to rotate. So that is kind of devices are known as output device. But the potentiometer, because we are going to adjust from 0 to some voltage. So we are going to read something from that kind of potentiometer or some kind of devices like that. So that kind of devices are known as input device. Okay. So here the LED pin, so of course that is going to be output. So we need to specify what kind of pin is. That is going to be like GPIO.setup. Before there is a set mode. So here we are going to set up. Okay, we are going to set up this LED as GPIO.out. So GPIO.out means we are just assigning that pin is nothing but an output device. Okay, so to represent what kind of device we need to represent, that is output device. Okay, so output device is done. Okay, so and after that, what we are going to do, there is a while true function. So what is mean by while true? While true means while of 1. So while of 1 means like it will look like this. So I hope you have programmed before like this, right? So while of 1, and then we'll write the program inside like this, right? So this is the basic syntax of C programming, in C programming, right? So we write the program like this. So this is the same thing which we did for here. Okay, so and you may ask, sir, like you'll put the braces in the C programming, but here we are not putting any braces. Yes, of course, Python don't need these kind of braces on this looping condition. Instead of that, here indentation is the main thing. Okay, so before in the C programming you may face error called this error, like semicolon is required, and you have to put the braces properly. But in the Python programming, you don't worry about those kind of braces and those things. So instead of that, what we are going to do here, in the Python, the indentation is the main thing. Indentation is in the sense braces. Like for example, this is the while loop. Okay, so this is the loop. Okay, so this is the loop. This is nothing but the meaning like. So I'll write in tree. Or I'll write the program in C. Okay, so that's it. Okay, so this is the meaning of in the C programming. Okay, while of 1 and then loop braces open and then semicolon and those things are there in the C programming, of course. Okay, so this is the meaning of this looping condition. Okay, so the indentation. Okay, the indentation is the main thing here, or else you may get irritated by seeing the indentation error. Okay, so first of all, GPIO.output. So first of all, what we are going to do? So here we are going to perform blink. Okay, so blink of an LED. So for that, GPIO.output of LED comma true. So okay, so here true, in the true, T is uppercase and other 3 letters are lowercase. Okay, so here there is a case sensitive because it is a keyword. It is not the user defined variable, it is a keyword. Okay, so true, T is uppercase and RUE, that is a lowercase. So LED comma true, which resembles that it's going to turn on the LED, but it don't know how much time it should turn on the LED and how much time it should turn off the LED. So for that, we are going to use a syntax called time.sleep. So here sleep means delay, or sleep means delay, how much time. If you want to specify, like for example, time.sleep of 1 means 1 second, 2 means 2 seconds. So like that you can able to calculate for hours and everything. Okay, So time dot sleep of 1 and GPIO dot output of LED comma false. So here this line will do turn off the LED. Okay, so turn off the LED and time dot sleep of 1. So which means it will turn on the LED for 1 second and again turn off the LED for 1 second. So still we just loaded this complete 4 line of code inside that while true, because while true is an infinite loop. So still it is an infinite loop. It will run continuously. Okay, so I am stopping it. So it will continuously like making like LED to be turned on for 1 second, turn off for 1 second, again turn on for 1 second, again turn off for 1 second. Okay, so that's up to here. So plus control yes, and then there is an option called run. Okay, so here there is an option called run and then run module. Okay, so LED is not defined. What is the error here? Because we have initialized the LED name as LED pin. Okay, so for each and every place we need to specify like LED pin. Okay, so I think you got the purpose of shell now. So both output and then error will be done in that shell part. Okay, so you just see the hardware now. So now LED is blinking. So on that blink you just can able to observe that LED is like turning on for 1 second and turning off for 1 second. Okay, so I hope you all observing the output here. Okay, so this is up to the basic digital write function. Okay, so like which is done in like Arduino. Okay, so we are going to write something like we are going to give some response, or we are going to give we are going to give some input to make it to be on or to make it to be off. So whenever we are here in the program, you are processing GPIO dot output of LED pin comma true. So true means supply will be passed over to that pin. The pin number is 2. So on that 2 pin, it will get that white wire. The white wire it will get now 5 volt, and in the ground that is going to be ground. But whenever it is in off condition, like GPIO dot output of LED pin comma false means, so that is going to be like 0 voltage. So while getting a 0 voltage, it will be turned off. Okay, so it will be like continuous, like on off on off on off. Okay, like switching off for in the while true function. Okay, so I hope you got this like digital like it is a kind of output. So if you want to write the terminate the code, you can press Ctrl C, or you can terminate like by closing this directly. Okay, better way to go for like a Ctrl C option. Okay, so that's up to here. Okay, so what we did up to now, like a digital output. Okay, we just give some input and we just observe some of the output. Okay, so now we are going to see the digital input. We are going to read something from the sensor. Okay, so for that here we have this IR sensor. Okay, which contains 3 pins. One is out, that is nothing but a data, and then VCC and then ground. Okay, I'm going to plug this IR sensor to the GP board. Okay, and we just take the jumpers, 3 jumpers. Okay, and just give it to the terminal. Okay, so 3 jumpers are here. So now we need to give the VCC and then ground. The green is going to be VCC and blue going to be ground. So you just see the pin diagram. Okay. Okay, let us take here 5 volt and then ground is required for us. Okay, the green is going to be VCC, the blue is going to be ground. Okay, let us give the connection. VCC second pin we can give. Okay, so third pin, that is the second pin VCC, and then ground is going to be green color wire, that is left side, that is pin. Okay, so now we have given 2 wires. Okay, so one is VCC and another one is ground. Okay, so on that so this is the IR sensor. The one pin is ground, so ground is given to the left side, fifth pin, and then VCC that is the right side second pin, so we have given that. So only one wire is remaining, so here one wire is nothing but a data. Okay, so on this data what I'm going to do, I'm going to give it to the third pin. Okay, so that is GPIO number 3, which is represented in the circuit diagram. Okay, so that's the connection. Okay, so third pin which is connected here. Okay, so that's up to here the connection. Okay, so I hope you got this. So we have given the connection now. So now ready to program. So same like, so first of all we require RPA.GPIO library, and time here it is not required. Okay, so we'll delete it, And GPIO.set mode, of course, we need to specify the mode of the GPIO pin which we are going to use, that is GPIO.BZM, and the switch. So we need to specify the pin that is 3. And in the GPIO setup, instead of switch comma GPIO output, so here we just specify that is a in. Okay, so IN, that is uppercase. Please have a care on, like it is a case sensitive. Okay, please care on it. And in the while true, we are going to read it. Okay, so on the previous code, actually let us compare the both codes so that you will get an idea, or you will get great comparison. Okay, so let us have this code, both code here. Okay, so you can able to see the difference between the input and then output. Okay, so here there is a code. Okay, so this is the output. Okay, so in this same as like the while loop is also open now, but instead of making GPIO dot output of LED pin comma true means it is going to give some input. But if you want to read some of the value, you can put like GPIO dot input switch double equal to 0. So double equal to 0 means, so if the sensor is giving 0, that means sensor is detected. If it is giving 1, that is positive volt or 5 volt or 3.3 volt based on the input, if it is giving that one, it is nothing but it means like it is not detected. So IR sensor can be detected by crossing the IR sensor with my hand like this. Okay, so if I cross my hand like this, that is detected. If I take off my hand, so it is not detected. Okay, so what we are done here, so we just introducing second looping condition. Before it we have seen a while loop, how it's work. So same as like if loop here. Okay, so now you can able to see the purpose of the indentation or the braces and all. Okay, for example, the while true is here, and then with one tab of indentation we have if loop. For the if loop we have another indentation. Okay, you just press the back press and you just come to here and press again enter. Okay, that is like print like sensor detected. Like if you want to introduce else condition, you can type else. So whenever you are going to write the program like looping, so you just come to backspace and make your cursor to be in the end of this line and then press enter. Don't simply place the cursor here and just don't start typing, then definitely you will face the indentation error. Okay, now we need a else condition. Else, so semicolon, sorry, that is colon. Colon represent there is something which is going to happen on the next line. Okay, that is the meaning of the colon here. Okay, print of not detected. Okay, so that's very easy, right? So that's it. We just pressed Control S. So I hope you know about, you are just getting this if and then else statement. Okay, so run and then run mode. Okay, now it is showing not detected. Okay, so now I'm going to cross this like cross my hand to the sensor. Okay, so now it is sensor detected. Okay, this is the actually this is the response, or this is the function of IR sensor to detect the obstacle which is before that IR and then photo diode. Okay, so it's like, so I hope you got this how it's working. So whenever I'm just crossing it with my hand, so it is showing sensor is detected. I'm just taking off this hand, it is showing not detected. Okay, so this is like if else. Okay, so I hope you understand the if else. So loops such as while loop and then for loop, so definitely we'll see in the upcoming session with each and every application. So on this today, we have learned a basic Python, like how to start with ideally and how to start with like addition subtraction basic thing. And we just started with the library like GPIO, that is wiring pi library. And we have started like how to initialize the pin as an output pin and how to initialize the pin as an input pin, and how to make like output that is like digital write of like true, so true or false, like giving high, how to make it to be high, how to make it to be like low. So with the help of this function, just like GPIO dot output. And if you want to read something from that certain module, so you can use the function called GPIO dot input of that pin name. Okay, so here double equal to 0 is optional, so you can also assign it to the certain variable and you can call it again. Okay, so double equal to 0, which is used for to read the sensor, because this sensor will give 0 whenever you are crossing this hand here. Okay, else is not it will else it will give the one or something, one value. Okay, so either 0 or 1, because it is a digital, because here in this Raspberry Pi it doesn't has inbuilt ADC, so here it can't able to read like analog values. So for that definitely we'll see in upcoming sessions like how to interface external analog to digital converter with Raspberry Pi. But in the Arduino it has inbuilt analog to digital converter, the analog pin. but here they're all completely about GPIO. GPIO means general purpose input and then output. It is not especially for digital pin, analog pin, so it is general purpose input and then. Okay, so I hope you got this. So this is basically like digital output LED and the digital input PAR sensor, PAR or anything IR sensor. Definitely it's going to be same. I hope you understand that. So that's up to like end of the session. Like it is up to Pantech course plan. Don't leave the session because we have a discussion today and we have question and answer session today and we have tech news today. So course plan. So on this course plan, this is about like 21,000 original cost, which is like $285. Actually, are going to provide it for only 499 due to this COVID. So this is very limited. Please register for the internship as soon as possible, because the purpose of the internship is in the YouTube you only get for 15 days, but in the internship you're going to get it for 30 days. So more agenda, artificial intelligence and robotic operating system you're going to explore a lot in the internship portal only. Okay, it is not available in YouTube. It is not going to be available in the YouTube. So please register the internship as soon as possible, because we are already providing the artificial intelligence course also. So you can combine the both course to develop your knowledge greater in artificial intelligence with and then without hardware. So the total cost is 1249. So you just want to register for this Arduino masterclass for 499. But for artificial intelligence, that original cost is 999, but we are going to only offer for 750 for the Arduino participants. So you can register for artificial intelligence as well as the Arduino as well as Raspberry Pi masterclass. The both every registration link is given below. So if you want a Raspberry Pi masterclass, please register as soon as possible. The first link given in the description, that is Raspberry Pi masterclass. Register for Raspberry Pi masterclass, then you will get the offer code for to avail artificial intelligence for 750 and BCA course for 99, that is 100 rupees. Okay, so I hope you like that. So and then daily science discussion is going on, because daily we are going to discuss something about science. So it is definitely making like informative, interactive and then interesting. I hope yesterday you just remember what is the concept, that is like theory of relativity. I hope you have that basic knowledge about theory of relativity. So you can start your discussion, you can post your answers or post your idea about theory of relativity. Okay, so I'm waiting for your like interaction. If you know about a little bit about theory of relativity, you can start your discussion in the live chat. I'm waiting for your interaction. You can interact me, guys. Okay, so Hardik Chauhan. So first he told E is equal to MC square. It's the very short form. It's really great. Yeah, that is E is equal to MC square. And Vishal Penuli, that is Einstein, sir. Yes, of course, he is Einstein. And Aniket Setpal, yes, Einstein. And Hardik Chauhan, mass energy equivalence. Yeah. Okay, so and then time bending, yes. And then E is equal to MC square, yes. Yes, okay, so let us discuss in detail. So my discussion, okay, my knowledge about that. So first of all, it's about relative motion. So relative motion in the sense, for example, now you are standing in here. Okay, so I'm going to travel in a vehicle. My and my friend. Okay, so my and my friend is going to travel in my vehicle. So I'm going to throw one ball to my friend. Okay, so both are standing inside the vehicle. Okay, so now both are standing inside the vehicle. Now I'm going to throw a ball to him. Okay, so that ball, actually the vehicle is already running in 5 km speed. So I'm going to throw a ball in 2 km speed. So my friend will receive the ball in only 2 km speed. But if I'm going to place my friend C in the ground, so I'm going to throw the ball to him, but he will receive on the 7 km speed, because already the vehicle is running. As with that, vehicle is running already in 5 km per second. As well as I'm going to throw a ball in 2 km, so totally it will be like 7 km. Okay, so that is a normal relative motion. On that, while talking about the light, actually that is normally, first of all, it is said like that, but light is not acting like that. Okay, because they can't able to receive, because light is this going to be constant. Okay, the speed of light going to be constant. Okay, so on the time it won't work like that. But for example, if I'm going to, instead of throwing a ball, I'm going to turn on the torch light. So speed of the light, that light will be there. So even he is standing here or even he is standing like in the ground, so he'll see the speed of the light going to be exactly constant. Okay, so that's the main concept that discussed. And time is not absolute. That is the main core value of theory of relativity, because actually now there is a two-person, me and then my friend. Okay, my friend is here. Okay, so my friend is in earth. Okay, now I'm going to take my satellite or something like that. Okay, I'm going to revolve this complete earth for 50 times. Okay, so complete earth I'm going to revolve the spaceship. Okay, I'm going to travel in a spaceship. Okay, so I'm going to travel in a spaceship. The time which is noted in here is not going to be same for the person or me. Okay, so actually I'm going to have one space clock. It is not a normal clock. So the clock one is with my friend, which is who is going to stay in the ground, and I'm going to take another same clock, which is set or which is synchronized with the same time, and I'm going to travel in the space. So on the time, definitely I get lagged on, because, for example, I hope you know about the Interstellar movie, right? So on that movie, he used to have his daughter. So on the climax scene, so he'll come to see his daughter. On the time, his daughter will get older, right? So that's the same. That's the basic concept. So space and time is nothing is different. So space and time is going to be same. Okay, but here, while talking about that kind of scenario, so Albert Einstein, he just discovered, or he just modified it, and he just told that time is not absolute. Time will be different based on the observer. Okay, like based on like here or in the space. Okay, so that's about theory of relativity. I hope we got some of the information about the science today. So I hope you like it. If you like it, please put I like it in your live chat. Okay. So and then discussion 3. So tomorrow's discussion, that is going to be like regarding the black hole. Okay, so it is like actually they took a recent picture, right? So we're going to have the discussion on tomorrow. Okay, so about the black hole, please have the quick overview about the black hole, and whatever the knowledge you know you just learned about the black hole, you can discuss it on tomorrow's session. Okay, so and tech news. So cause of a lot of participants who have requested to add these kind of tech news for daily, like to continue the tech news as like we did in artificial intelligence masterclass and Arduino masterclass. So we are going to continue it. Yeah, we are getting thank you response from the Revati, Niveda, Nivi, and Jaya Nandavar, and Aniket Sakpal, and Twinkle Verma. So, yeah, it's really great. Thank you so much for your response, guys. So it's making me to give a lot of knowledge to you. So thank you so much. So tech news of day 3. That is actually the brain. No, so here they are just manufactured one device, one sensor is manufactured, that is with the help of artificial intelligence, that is serotonin sensor, which is helpful for studying the mental health. Like actually, apart from other healthing issues like physical health, there is a lot of mental health like pressure and a lot of thoughts. So we need to analyze lots of thoughts there. So with the help of BCI technology, right? BCI technology is already doing that. So on that list, so we are that one sensor is discovered with the help of artificial intelligence. So which is very helpful for actually to analyze the brain waves, especially that serotonin part. So which is helpful for analyzing the sleepy stages and mental health. So to analyze that new sensor is developed now. So it's really great to inbuild with artificial intelligence, because normal sensor will perform well, right? Artificial intelligence with the sensor, it will learn well. Okay, it will learn and it will improve itself. A normal sensor, it won't improve. We need to modify the sensor, but artificial intelligence with the sensor, it's going to learn and it's going to improve itself to have a better classification or to have a better recognition to each and everything. Okay, so that's the main purpose of using artificial intelligence. It's really great. So I hope you like this tech news of today. So on daily, definitely we're going to have tech news. So we are in the Q&A session. Okay, so you can ask your questions, guys. And another main thing I wish to say is this New Year offer is going on for each and every master class, which is given in the description below. You are going to get 250 rupees offer. Okay, so if that is if it is 750 original cost, then you'll get it for 499. If its cost is 999, you're going to get it for 750. Okay, so please grab the offer. Only like 2 days is there, right? Grab the offer. You just train it. Okay. So it will be very helpful for you. Which pre-trained object detection model will run on Raspberry Pi and high frame rate like minimum 10 to 15 FPS? That is for frame rate in the sense you can go for basic mobile net SSD. If you are using a YOLO, definitely it will be like a little delay there. But if you are going to use some kind of accelerators, definitely you can able to see the high frame rate. What is the ohm value of resistor do you used with the LED? Actually, we have used 330 ohm resistor. Okay, so that is the resistor 330 ohm 330. Okay. In code, we have selected BZM pin code for board pin. No, it is BZM pin. GPIO there it is represented as 2, right? So it is not necessary to represent GPIO 2. Okay, so here it just simply put 2 means. So here we have already initialized that is a BZM. So it will directly call GPIO 2, not a normal 2. Okay, hope you got it. Difference between artificial intelligence and machine learning. Actually, artificial intelligence is a larger circle. Inside that larger circle, machine learning also one of the part. Inside that machine learning, there is another core part, that is a deep learning. Okay, that is completely artificial intelligence is a father. Okay, so and then like child, so that is like machine learning. So that is one of the part of artificial intelligence. Suggest me a Raspberry Pi simulator. Actually, a lot of people are asking for the simulator for Raspberry Pi. It is not advisable because the circuit which I have shown, that is only like circuit drawing for which I have used for circuit IO. But other than that, definitely I'll check for it. But it is not advisable. But directly go for the hardware deployment. Then only you can able to see lot of problems and errors. Okay, so definitely be helpful. Abhishek Ghosh, sir, can I use PyCharm or VS Code in Raspberry Pi? Yes, of course you can use PyCharm. Actually, you need to go for like SSH terminal. From that, you can able to do that. Okay. How to know which pin to select? That is a great question, Ankit Ray. Actually, that pin based on like GPIO. So everything is going every pin going to be the GPIO pin, except ground and then VCC. You can use every pin for the data. Okay, so that's a great question. What is the voltage we are getting in the output side of the Raspberry Pi? On the output side, the pin two pin output is there. One pin is 5 volt and another pin is 3.3. Okay. So and I already told you, please don't accidentally don't short the 3.3 volt and then ground. Definitely you need to change complete Raspberry Pi. Any whatever will be the board, don't short, don't accidentally. Please be careful whenever you are giving the connection. Okay. Uh, Arduino versus Raspberry Pi. Which one is more suitable for doing projects? While doing project that is based on application. If you're going to work on only IoT and only embedded system, go for Arduino because that is cost effective when compared to Raspberry Pi. But if your application requires a camera and further lot of artificial intelligence kind of application, go for Raspberry Pi. How to remove OS from Raspberry Pi? It's very simple. Take out the SD card, put it in the card reader, and on the yesterday session we have used the Rufus application, right? So with the help of that Rufus application, you just put non-bootable mode and you just click the format. So you'll get the fresh SD card. How will load the program to the board? That is first case. You can write the program there. If you want to load the program manually, like from artificial intelligence class, for example, if you are an artificial intelligence participant, if you want to load that code into the Raspberry Pi means it is not necessary to write. Please use the fresh on SD card or pen drive. Okay, formatted with FAT32 because don't use EXFAT because EXFAT format it won't support Raspberry Pi. So format it with FAT32 pen drive. So on the pen drive you just drop each and every like every codes which you want, and then you just put the pen drive in the USB port of the Raspberry Pi. There it will open the dialog box to open the pen drive. So simply like as like Windows, Just select the folder, Control Z, copy, and just go to the folder where you need to paste, Control V. Okay. Can I use Jupyter Notebook? Yes, of course. Can I also install Jupyter Notebook? Is it possible to power the Raspberry Pi from external battery? If possible, then how? Instead of asking about battery, please use a power bank. Okay, so that is advisable because standard supply we need, right? So standard supply in the sense 5 volt and then 2 amps, like 5 volt and then 2 amps current. So we please better to use power banks. This for wireless advisable. Okay, I think we are running out of time. So thank you so much for attending the session. So if you want to know about more masterclass series, you can visit learn.pantechsolutions.net. On the left top corner, we have that picture of each and every course, like brain computer interface, masterclass, MATLAB masterclass, artificial intelligence masterclass, Arduino masterclass, and etc. So if you want to know, you just want to visit learn.pantechsolutions.net and you just click all courses. There will see a lot of courses. And if you want to avail that 499 offer, the link which is given in the description below, register as soon as possible. New Year offer is also going on, only 2 days remaining, so please register as soon as possible and grab the offer. That is up to like 499, which costs about like 750 course. This is given for 499, and 999 course is going to be given for 750. Please grab the offer, register as soon as possible. It is a very limited offer and quarter of this day. The important thing is to never stop questioning. So as per the quote by Albert Einstein, don't stop your questions on the Q&A session. Please grab that timing and ask as much questions what you need. Okay, if I know, I'll tell you. If I don't know, definitely I'll check and I'll update you. Okay, so and if you need any technical questions regarding these sessions, you can post your questions in the internship forum. And if you are an YouTube participant, you can post your questions in the YouTube comment box below. Okay, so thank you so much for each and every participants who ever interacted with me, and lot of questions have risen here. So still now I can't able to reply for each and every question, so please raise your questions in the forum portal. So thank you once again, guys. So thank you so much. Thank you so much. It's me, Sanjay. Until then, bye. We'll see you on the tomorrow session.